Welcome to Commencement into Real Kubernetes Security, challenging what we think we know about securing Kubernetes. My name is Mark Manning. I go by Antitree. I'm a Rochester native. Anybody from Rochester in here? Yeah, exactly. There's a lot of us here. I used to work at Snowflake building RCs as a service stuff, and I worked at NCC Group as a pen tester for a long time doing the container security practice for them.
Hi, I'm Jay Beale. I'm a CTO at InGuardians, where I lead our Kubernetes penetration testing and cloud penetration testing work. I help create the Kubernetes Capture the Flag at DEF CON, so please come play. I also train Kubernetes attack and defense at Black Hat, and I like building open source tools like Bastille Linux and Paratis.
So we've been working together for a while. We actually met at ShmooCon, and we were comparing notes about Kubernetes things that we've seen in consulting against Kubernetes clusters and reviewing and breaking them and building Kubernetes stuff. And we saw a bunch of commonalities, and this is kind of the premise of the talk. So for any nuanced technology, there's often this like disconnect between what we're supposed to do and reading the man pages and the documentation, like yes, we know it's supposed to work this way, and then the real world stuff, right? The stuff that we see that's actually happening. AWS buckets are still public and open, even though there's like 10 million warnings on them. Active Directory is still getting owned in Windows world. Kubernetes roles are still overprivileged. So what is the problem that we're running into? Many of the talks that you've seen are probably going to focus on the misconfigurations. Today we're going to focus on what you should be putting your focus into. We're going to talk about the practicality of both attacks and defense of Kubernetes clusters. So I'm hoping that you come back with like a more nuanced perspective of the practical things that you need to be concerned about for Kubernetes and some of like the nuance that has to go into defending it. Get a better understanding of the real world scenarios that attackers could be using and applying to your organizations. We'll go through some demos. And we got a few new tools and tactics that we can talk through. Some of you may have seen this type of slide before, but humans are just really bad at risk analysis. We kind of think about the scariest risks first, the stuff on the top left, and we go, oh, this is the ones that I need to defend against, and then there's the actual risks that we should be more likely defending against in the bottom right. We feel that the risk is over here, and like this is true for a lot of the technology that we're going to be talking through. So there's a bunch of different roles in your organizations. As you're trying to secure your environment, we don't just secure it yourself. It's not just only your job to secure this stuff. You've got a bunch of other teams that have their specific roles and the stuff that they're supposed to be doing. Like your boss is going to be asking you, hey, how much does it cost to fix that thing? Compliance is going to be asking, where's the proof that you fixed that thing? Your board of directors are just going to come back to you and say, like, did you fix it or not? I just want to make sure that it's there. And the SEC is like, why did you even do that in the first place?
Okay, so remember this is ShmooCon Commencement. You're preparing for your graduation. You're going to see this theme in our slides where we're talking about kind of like what you learned in school, what you learned, what you took away from the books, and then we're going to talk about what you're going to find out in the real world. So welcome to graduation. Quick agenda and background on Kubernetes. So Kubernetes, if you don't know what a Kubernetes is, that's mostly okay. Chase me around the conference, and I might give you one of 3 books we brought with us. Anyway, Kubernetes orchestrates machines, so nodes, computers, into running containers into a cluster to make it self-healing, scaling, and automatically choosing where to put stuff. So this talk is actually going to hit Kubernetes all the way down at the level of the Linux kernel and processes in it, up to the node, up to the cluster. So we're going to be looking at kernel level, where we're talking about system calls and breakouts, and Linux kernel. We're going to be talking about the API level, and we'll be talking about it when we get to own clusters. So, cool.
So for any one of these like Kubernetes talks, we have to talk about breakouts, and we have to talk about the sexy fun side of things. So runtime security, container breakout stuff, we'll start diving into first and kind of give you the primer on, hey, what is a container? And if you remember, containers in my mind are kind of these filtered views of running processes. They're not virtualization. They're not isolated in any meaningful way besides what the kernel can do. So the container that you're running might have a host name of Holt, and the other container has a host name of Toby, and different IP addresses. But in reality, those processes, those containers, don't have those true names. They're just representations inside the kernel. So we use this to kind of pretend that we're isolating, pretend that we are separating all of the stuff, but they're really just processes that are interacting with the kernel. And in the same way that like any process interacts with the kernel, we use system calls, execv, openat. These are just ways of like opening a file, reading a file, running a process, like loading it into memory, executing, and all that kind of stuff. So every single thing in Linux just runs with these system calls, and every kind of kernel operating system operates this way. So instinctively you might go, hey, I've got these containers, I'm really concerned about breakouts. Breakouts always come through system calls, so I'm going to say I need to restrict the system calls that are happening from the container. I don't want it to get into my kernel. And there's a bunch of technology that the kernel already has for this stuff. Seccomp BPF, landlock is kind of the new thing that people are talking about. LSM, BPF, maybe even newer. These are ways of filtering the stuff that gets into the kernel and making security decisions on your behalf. So the stuff that we've learned about in school, right? This is our commencement. Let's talk about the stuff that we've probably been saying even at a ShmooCon. We'll say things like, hey, containers are not a security boundary, and this is true. Containers all share the same Linux kernel, therefore they're more dangerous than virtualization, and also true. Linux namespacing is not sandboxing. We'll talk about like why that's true today, and we'll come to these conclusions and say stuff like, if you really care about security, then you should be building custom Seccomp BPFs that filters out the system calls that go into the kernel, or run some like runtime tool, some CNAP or something like that. So we must defend the kernel from all these container breakouts, right? That's our responsibility for running Kubernetes. So in my mind, and in talking to Jay, we kind of had this conclusion that there's kind of these two modes. One of the, is the mode where we're running Kubernetes kind of like a remote code execution as a service. And I love these environments, and this is the kind of stuff that I work in, and this is kind of stuff I did at Snowflake. It's fun, it's dangerous. Obviously we know we shouldn't be doing this, but there was like one day that somebody said, hey, we can run Kubernetes like a sandbox. Containers can be a sandbox, right? Why don't you go reinforce all that stuff? And this is where the scenario of like, hey, maybe I'm going to take a customer image, I'm going to load it into my Kubernetes environment, and now we have to protect that environment. So I'm going to do a quick poll, so wake everybody up a little bit here. Not a trick poll, there might be some in the future. How many people here are kind of building Kubernetes environments or running Kubernetes environments that fall into the remote code execution as a service category? All right, oh, I love that. And what about the rest of us that are running Kubernetes that just like run Nginx and do something simple, right? Like, yeah. So I tallied up all those hands automatically. I used some AI, right? And it actually came out how I feel. There's a bunch of organizations that are doing the RC as a service. It's super dangerous. It's exciting. And then there's the rest of us that are kind of like, hey, I got this Nginx or this Helm chart. I just need it to run, man. Like, whatever. And then there's the subcategory of the people doing RC as a service that are doing it safely. And like that's what we're going to kind of aim at today. We'll see. So you might go, well, there's a bunch of CNAPs, there's a bunch of runtime tools. How do we find the perfect tool? Let's come up with a list of all the most exciting vendors that can solve us with eBPF and LSMs. It's got to block malicious activity. It's got to detect container breakouts. It never can cause a production incident. You know, it's got to be cheap. It's got to be performant. It's got to be perfect. You know, an impossible list, but we've got this big space of vendors that are doing interesting stuff. Falco, for example, a lot of people have heard, will do runtime analysis of system calls of your Kubernetes environment and tell you, hey, this system call looks a little dangerous, I'm going to go do something with it. A lot of these are kind of cloud security posture management tools, but like here's what our options are. Each one of these options have the same challenge. They could be eBPF, they could be Linux security modules that get loaded up. They're doing something really interesting in the kernel on your behalf to kind of secure the kernel. But the Linux kernel itself has a bunch of challenges, and some of you may know about the things I'm about to talk about, but this isn't about how bad the runtime security tools are or dangerous they are or how they're doing something wrong. It's just how, in order to do this, they have to face a bunch of interesting challenges. One of the main ones being, a lot of the system calls that we've been talking about for containers have a time of check, time of use issue, where if you're monitoring the system call and you're saying, hey, I want to do something with it, it can be manipulated between the time that you checked it and wanted to see, like, oh, is this an attacker, and the actual time that's being used by the attacker. So I'll give you a simple example here. We can say, imagine like a file reader, right? all it does is read temp test. And we've installed that BPF tool that's really cool, and it hooks sysenter. So we have all of the system calls going into the BPF tool. Now we can see, hey, I see that your container's opening temp test. And it goes, that's cool, I don't mind that. And then in the same way, you can set up a policy that says, hey, my container is opening Etsy Shadow. Oh, hold on a second, I want to block that. So there's a bunch of tools that will do something like this, and it's capturing on sysenter all the system calls as they're being created get sent over to the BPF tool. BPF tool can make a decision. If there's a window of opportunity that you can p-trace even your own process, you can manipulate your own system calls. So in this scenario, I'm saying there's like this p-trace supervisor over my file reader now, and I can hook that system call and replace the parameters of the open to be now Etsy Shadow instead of temp test. So now I'm opening Etsy Shadow in the actual kernel, so everything in the kernel, I read the actual Etsy Shadow. This passes the BPF runtime tool that we paid a bunch of money for, and now we can access that. Now this isn't necessarily the problem of the BPF tool. They didn't do anything wrong. This is the best that they can do. This is the facilities that the Linux kernel provides. And if you wanted to check from this type of attack, you can hook sysenter and you can hook sysexit, and then you can kind of compare the two. And the problem here is not that you can't do that. This totally works. It's the issue of performance. I've now 2x the amount of hooks that I need to run into to find these system calls. And I've loaded into some kind of buffer so I can compare the parameters. So I've got a ton of new I/O that I'm running and another bunch of like CPU. So it's a complicated problem that isn't really solvable perfectly. And tools know about this. If you look at Tracy's documentation, they'll say, hey, we have tracing, and then we have secure tracing. And secure tracing lets you run an extra LSM on top of the entire BPF program. The BPF program will hook sysenter and sysexit, and then the LSM will also check for time of check, time of usage, your race conditions. So the complexity of this thing is just getting more and more. Like, right, we've got like LSMs that are just monitoring our BPF programs, and it's getting kind of resource intensive to figure out if we can mitigate these threats from a container breakout. So what we learned in school maybe is breakouts happen because we aren't hardening our container configuration, and that's totally true for a lot of scenarios. But also, container O-days aren't necessarily happening to organizations on a daily basis, and most of us have to balance the practical threats and the people that are not building RC as a service, and the ones that are like the most meaningful, the most likely threats, and we'll talk about that more later. The people that are building RC as a service are still fun, so let's talk about some of that scenario. So a real world situation that I had was an organization came to me and they said, hey, I've got this function that's a microservice, and all it does is it takes in an image from a customer and it lets them upload some like avatar, and then it just resizes it through image magic. Now, anybody feel that image magic is secure? Anybody want to raise their hands on that? Yeah. So they felt the same thing. It's just like there's never going to be an opportunity to secure image magic, so let's harden it with a custom Seccomp profile. And it seems like a good idea because this microservice has just one job, so let's confine it to only that one single job. And that's what they asked me to do. So in doing this, we have this format of Seccomp BPF. We can apply this to a bunch of containers. There's this JSON format that lets you just define them, and it's pretty simple. The open@ system call, we're going to put that in there. We're going to say whenever there's an open@, I want you to log it. You can kill it, you can allow it, you can do a bunch of different kind of actions on each of these things. So we've got this way of saying, I want to allow all these system calls, I want to block all these system calls. Then we just need to generate the system calls that our containers need, so that our image magic thing needs. So if you've been around a while, you might know about this tool called strace. It's been around since the beginning of time, right? Like, that still works here. It just dumps the system calls that we need for our container. There's some newer stuff like Zaz that will profile a container. You can run it, you run your container, tell it to do some activity, and just spit out the system calls that you need. OCI, Seccomp, BPF, Hook, and Inspector Gadget are all kind of more modern takes on this, where they're taking BPF and saying, hey, give me all the system calls that my container is doing while you're exercising the container and trying to make it emit all the system calls that you think are relevant for your custom Seccomp profile. So let's say this is successful. We've come out with this nice list of system calls that we need. We now have this profile. We now need to manage the profiles in Kubernetes, because right now it's just a JSON file. What do we do with it? The smart people, I think at Red Hat, built this security profiles operator. And the main goal is just take that JSON file, load it into a Kubernetes, make it an object in Kubernetes. So cool. let's put this all together. It works out pretty well. We've got Inspector Gadget, which is an awesome tool if people haven't worked on this and interested in low-level Kubernetes stuff. And we've got the security profiles operator that's going to manage stuff. And we can even check in the Seccomp profiles that we're making for each of our repos and for each of our projects. So this fits into our whole infrastructure as code thing. But we run into some other issues of okay, with anything that we're running in production, now this thing is super scary. The security profiles operator is in a critical path for production. We need to be talking to engineers who are building this thing, they're coming back to you and saying hey, for some reason I ran through your tools and it says clone doesn't work. I don't even know what the clone operation is. Can you explain the system call? And then the real big problem that I've seen is that the containers themselves, if you ever accidentally block a system call that you shouldn't have, they get into these weird pause states or unrecoverable states. So your programs aren't necessarily designed to figure out what happens when a system call isn't there. But did we do our job in our main goal of securing the image magic thing and protecting it from all the malicious activity that could be possible? Let's take a closer look at that. So another quiz. Sorry, it's early. We're going to do this. I want to know, where is the Seccomp profile being applied? So this is kind of a representation of, container D running in Kubernetes spins up a run C instance, spins up a container in the grandchild process, and then eventually, I just want to run Nginx. Where do you think the containerized process exists? I'm going to need someone to just yell out answers. In the kernel? Okay, any other answers? Container D? Yeah, it's the whole thing. It's the entire container, it's the container D, it's the run C instance. So when we do the filters on all this stuff, we have these really interesting results where our custom Seccomp profiles may not be as secure as we wish that it was. They restrict a whole bunch of more system calls, if you look in the list, and we'll show that in a second. But we have to capture all the system calls in strace and all those Inspector Gadget tools. We're also capturing the clone and some of the dangerous things that are normally part of the container. They're privileged operations. So here's an example. I just wrote happy ShmooCon in C, the simplest application I think I can try to write. And then I ran strace on it. And you can see during its execution, happy ShmooCon emits 17 system calls in total, and maybe there's a dozen unique system calls that this thing uses. Now I'm going to bake this into a container image. It's the exact same thing. Use Alpine because it's minimal. And I'm going to strace the same thing again. And if you remember, the last one had 17 system calls that it made. The new one has 1,888. And not only is there a bunch of more system calls, but there's some dangerous system calls that happen through this. So if you look at this happy ShmooCon image that I created in the custom JSON for the Seccomp profile, there's some stuff in there hey, why does it open a socket now? I just did basically a hello world. Why is it allowed to do clone, which is one of the system calls that you need for cloning into a new namespace or making a new container? So because I tried really hard at building a secure container, I actually shot myself in the foot. So I built this tool called Seccomp diff, and the whole purpose of this tool is that it'll ptrace the pod, extract the Seccomp profile. I wrote an entire disassembler for the Seccomp BPF stuff. So it'll take the original bytecode that's coming from the kernel and spit it back out so that you can actually differentiate, am I building a more restrictive profile or not? So I didn't have this capability before, so I built it for you. You're welcome. Here's a demo. This is the web interface. It's also command line. You can choose container D or Docker for your runtime. Let's list a whole bunch of containers. I happen to be running, a couple called Shmoo, but you can run anything in the whole cluster. I'm going to run happy ShmooCon default. It's going to be the runtime default, and then I'm going to do happy ShmooCon with my custom container, and let's compare the two to see what's actually different. And the first thing you're going to see is cool, everything looks like there's more denies in my custom one and there's more allows in the default one. That seems great so far. Now if I restrict that to, this is just the diff, so if I restrict that to just the dangerous system calls, we kind of hone in on one of the problems, which is hey, we allowed clone and we accidentally for some reason allowed BPF, and I truly traced it to come out to BPF and I have no idea why it needs that. BPF lets you load any kind of eBPF program. You can take over the entire kernel from that. Here's the JSON that comes out of that. The clone and the socket are all part of the thing. And then you can also look at the disassembled code if you want to look at the raw jumps for the entire program to figure out what's going on. Thank you. If somebody appreciates the effort on this. So if anybody's interested in Seccomp diff, you can go get it right now. There's a version of the command line tool. So cool, Seccomp BPF can harden your containers. There's nothing wrong. I don't want to say that that's an exploit in Seccomp BPF. It's just like it's hard, and it's hard to do correctly, and it's not going to make things into a sandbox without a whole bunch more effort. So we have the option of Seccomp BPF, super performant, works really good in static environments, even probably a good use case for that image magic thing I was talking about. Just not great for if you want to scale it to every single container in your organization, and also not great for if you want to have like a small team that's managing these resources. It's super high risk. And I don't want to spend too much time on gvisor, but I do want to highlight that about 2 years ago to the day, gvisor came out with a new update that they kind of subtly released that improves I/O performance. So if you haven't looked at gvisor in the last few years, take another look at it. It solves, if you really care about the the RCE as a service stuff, it solves a lot of that stuff that we're worried about. If anybody's been around, you know where I'm going with this. If anybody's been around long enough, you can see this parallels with SE Linux, where we go like, SE Linux is super powerful, it's super complicated, and it's really easy to shoot yourself in the foot. Seccomp kind of has those same things, where it can do a whole bunch of really cool stuff, but you kind of like defer to some of the professionals to handle this. So the people that are doing RC as a service, awesome, it's exciting. Maybe we do want to do gvisor, maybe we do want to Kata containers and Firecracker and like all these like really fun stuff. But and maybe we do want to like really figure out the risk analysis of like customer breakouts, because it's an active threat that we need to mitigate. But the rest of us, our main priorities might not be there. Our main priorities, as Jay's going to talk about, are kind of like clusters that might be misconfigured with RBAC problems. And at the kind of bottom of the list is that super sexy headline that you saw on the register about like, supply chain Docker O-Day compromises Tesla or whatever it's going to end up being, right? That's not the threat that everybody needs to be mitigating today. But for the people that are just running Nginx or just basic Kubernetes, the Seccomp default runtime actually is more secure than trying to build custom ones.
Yeah, and a shout out to Jess Frizzell, one of the Docker maintainers, who put a ton of time into that default Seccomp profile. Cool. Well, let's look at things, let's move all the way up and look at things at the cluster level. So I'm going to pick on compliance just a little bit, but before I do, let's give some credit to compliance. So compliance in orgs, they're really good with anything that fits well on a checklist of well agreed upon things. And so compliance has done a really great job of driving us to using MFA on every web application humans use. Compliance has gotten us to patch more often than once a year. They've gotten us to use longer passwords, avoid using really weak crypto systems or using too few bits. But compliance, and we're beating up on it, but honestly, the checklists, they can give us a false sense of security. We can feel like we're getting things right. And so I'm going to pick on two of the big ones that come out there. The one is compliance saying, hey, all of your image CVEs have to be eliminated in N days. The other we're going to talk about compliance is you have to do everything in this hardening guide. So first, let's talk about that CVE. Really helpful to underscoring this point. Jake Williams made this point on Twitter and probably on Blue Sky as well a couple weeks ago, and said, "Hey, the cybersecurity industry is wasting a ton of time remediating vulnerabilities." In things where the program wasn't vulnerable, the library was, and the program wasn't used in the library, so the program wasn't vulnerable. And I ran right into this on a really recent pen test, where a client said, "Hey, I know it's not really part of the Kubernetes practice, of the Kubernetes pen test practice, but we have this runtime security tool. We want to see if it's doing its job. So our CNAP is giving us a list of all of the images that have CVEs in them. Can you just exploit, one of these?" And they gave me like 4. And I went through and I looked at all 4. And I'm like, wow, I can't exploit any of these 4. I'm sorry, because it turns out they're not vulnerable. They're like, the image has CVEs. Like, yes, the image has libraries that have vulnerabilities in them. But it turns out A container starts generally with one program, like Mark was showing. It starts with one program, and maybe it'll launch some others, but generally, one program is a workload. That's what goes in our container. And what I said to them was like, wait, this program, the main program in this container, never uses that library. The main program in this container uses the library, doesn't use the vulnerable function. The last one, this one, uses the library, uses the vulnerable function, but there's no path from there's no path from the program attacker input going into the function's parameters. So what you've got here is CVEs in images without vulnerabilities in their containers, and you're spending a ton of time chasing all that down. So that's kind of like the first item in our checklist. The next one is the CIS benchmarks. And the CIS benchmarks are actually really, really good hardening guides, but they're focused, and they're very focused on, and so many of the tools, both open source and commercial, are focused on kind of telling you, okay, which items do you pass, which items do you fail? Unfortunately, there's a ton of items that are manually checked, that are like, tools can't check this. This is a judgment call, it's manually checked. And unfortunately, as you're going to see in my demo, the RBAC and admission control, like pod security standards, are the two big areas where there's a lot of great advice in the benchmark, and they have to be manual. So what I'm going to do to kind of prove my point or support my point is I'm going to take a micro K8S cluster that is hardened with a great CI security add-on that comes right with it. You just enable the add-on, it hardens the cluster, so now you get no failing items on the CI from Kubench or from any other tool that checks things against the benchmark. And we're going to take this compliant cluster that has no CVEs, and we're going to attack it. So let's get into it. You're going to see two tools here that are open source. One's KubeHound from Datadog, the other is Paratis, something that I and folks at Guardian started and open source community helps out with. So let me just get into my demo. So we are going to hit your commencement from ShmooCon University. I made sure to avoid the trademark. And let's assume that we are students, we're on our way out, we've got senioritis, but we have access to the data science cluster, and so what we're going to do is just log into that data science cluster. This turns out to be Jupyter Hub. I've skipped right past the Python stuff and brought up a terminal, and we're going to see what we can do from here. So I tried getting pods. I couldn't do it because it turns out there's no service account token mounted in. They've done something well. Almost none of our pen tests have that, but that's the best. So I'm going to try to go lateral. So inside Kubernetes there are load balancers. There are internal load balancers. So all the services, those internal load balancers in my namespace, every container running in that namespace gets IP addresses and ports for the load balancers. So cool, great way of getting service discovery. So I'm like, okay, well, there's something called grad student service host, so let's curl that. Okay, and we couldn't see this in the browser, but just to make it a little more beautiful, just to make it a little more beautiful, I do have an image, but anyway, this says, hey, grad student Jupyter Hub is undergoing maintenance. Use the one that, well, we're using right now. But it also mentions this code server, like VS Code in the browser, that you can find over here. Oh, well, that sounds kind of cool. That sounds like a nice way to go lateral. So let's go check out that code server. It needs a password. Let's stipulate we tried password attacks. They didn't work. So let's go explore the container some more. So going back over to our Jupyter Hub, we look at the container, and I do a PS, and I see there's my process, but there's this other process. There's this pause process in here. That's not something that's part of my workload. That's not part of Jupyter Hub. And then there's also this other thing. There's this Node.js server. So what it turns out I can see here is that I have multiple containers in the pod, and they're all sharing the same PID namespace. So cool, that means I can go and take a look at one of the other containers that are in here. I don't have a service account token, let's see if it has one. So I'll go and follow proc, and I'll go look, and I see in its current working directory this nice little service account token. Well, that's going to be super helpful. So we'll cat out that token. I'm going to set up a kubectl alias that uses that token right off the file system. I'll call it K, and I'll do get secrets, and this thing tells me, hey, this is your service account, your Jupyter Hub default. Okay, cool. I'm going to set up another alias, KJ, for kubectl Jupyter Hub, and make it, all my KJ commands will be in that namespace. So I'll say, okay, what can I do? KJ, can I list? and it says, okay, hey, you can patch pods. You can't create pods. I'd love to be able to create a pod, because I can create a pod, I might be able to get toward container breakout. So I can only patch. Well, that's cool. It means if I can find one of the other pods in the cluster, I can choose one of these, and I can put a different container image in it, and I'll get execution there, and if that thing has a good service account, that'll give me privileges I didn't have already. So I kind of looked at those. I got to figure out which one I'm going to choose. I ran another command to just get a list of what the service accounts are that are in each of those pods. So I see this one called Hub that's being used for the grad students thing, and also for the Jupyter Hub I must be using. I found that code server one too. But that Hub one looks plenty interesting. So what I can do is I can start at my own cluster, on my laptop. I can install Jupyter Hub from the Helm chart and see what the permissions are. So that's what I've done. I've looked at the Helm chart, and it looks really nice. This thing can create pods, and it can get and list all the secrets. Both of those are great. I want to be able to create my own pods, so I can try to create a privilege. Maybe I'll create a privilege container. Spoiler alert. And also, I want secrets. I want the secrets. And the reason I want them here is because, unfortunately, ShmooCon University does what almost every pen test client does. They lock the cluster down to only they don't allow you to pull from Docker Hub. They only allow you to pull from their registry. But that means you're going to need credentials. So I need image pull secrets. But great, if I can read all the secrets in this namespace, I'm going to get them. So cool. I got to figure out what image to use. Well, this one looked good. That code server, that VS Code as a service, that'd be nice. That sounds like code execution to me. That's good C2. So I'm going to take that ability I have to patch pods. I need to figure out what image the code server uses. So I'll just get pod grep image, and I find a nice little hint. Looks like there's a policy that says, hey, whatever you do, don't use code server anon. So we're hackers. What does that mean we should absolutely do? Especially if policy forbids it. Okay, so policy forbids using code server anon, use code server. The one that we're hitting that had a password uses code server. So cool, we're going to patch our pod. We'll patch the grad students, that Hub grad students pod. The one that came up and said, hey, this is broken, sorry. Let's be helpful. We've been attending this university for 4 or 5 or 6 or 8 years, 20 years. We are old students. So, let's fix something on our way out. We'll fix the grad students hub. So we'll replace that image with one that works, hopefully. So we'll deploy that code server anon image. We've patched, and here we are. As soon as I patch that, I've got VS Code in a browser replaced in that grad student hub. VS Code's helpful because, there's a terminal. So cool. Let's take our terminal. It's not root, but I won't need it. That's just fine. And I'll grab a copy of kube control. I'll set up an alias to use the Jupyter Hub namespace, and I'll ask, hey, what service account do I have? I've got Jupyter Hub. So I remember Jupyter Hub's pretty powerful, but let's just confirm that it's the same in the cluster as it was in the Helm chart. Yup, Jupyter Hub's allowed to create pods and get secrets and so on. So I'm going to get a list of secrets. There's that image pull secret. I'll go and decode that image pull secret. Do some grep and awk and base 64 decode. I love Linux command line with a passion, and Kubernetes loves that. So I've got Mork and Mindy as a password. That sounds like a very old TV show that was, before my time. So we're going to build our own container image. This container image is just Alpine with an interpreter reverse shell binary and a copy of Paratis. And so I'll push that container image into the registry. Now I'm going to launch a pod with it. So I've set up a privileged pod definition. So this pod definition has two things. It has this host PID namespace, and it has my make container here privileged. So those two things give me container breakout. You shouldn't see privileged pods anywhere in any of your workloads. You should find them in infrastructure, and every time you find them in infrastructure, you should do like I do and tell somebody that they will rue the day. But they'll be necessary in parts of infrastructure. So anyway, as soon as I stage that pod, I get a shell out of the MSF console I've already set up. I I'm going to run that NSEnter command and say, I want to target PID1, and I want to enter all of PID1's namespaces. So that PID1's like init or systemd. And as soon as I do that, I'm out to the node. So I'm on node 1. I can kind of look at all the network interfaces and say, those aren't the ones you'd see in a container. So I'm going to just go find that prioritization binary that I brought in the image. It's somewhere out on the file system on that node. I'll copy it in the user bin, and I'm going to run it. And prioritization, as soon as it starts up, when it runs on a node, it just hoovers up the kubelet. It grabs the kubelet certificate and secret key to authenticate as that node. It also finds every service count token that's being used by any pod running on the node, stores those tokens up. And we're going to use one of these. We're going to use that metal-LB one a bunch. It also finds the secrets, and if they're certificates, it'll find their CNAME, it'll parse them out, and even tell you, like, here's where you can find them on the file system. So there we go. So there's a TLS key. I can go and look at that. I'm actually not going to look at it in the interest of time. Recorded J apparently was starting to decide to do that. So I'm going to, Prioritization has the SA menu certificates. I'm going to use these three things, kube control and kube control try all. So I can run kube control commands in Prioritization, and I can do it as all of these service accounts, all the ones that we hoovered up, as well as the kubelet. So I'm going to do this try all until success. And we have a kube control try all, try this as every one of the service counts, but on a pen test, a couple of the people at InGuardians, Rob Curtin, Seifert, and Jareth Kelly were like, hey, can we modify this so it just doesn't do it as all of them, because there are like 85 in here? Just do it until you find one that works. It was like, cool, that's a 5-line change. Yeah. So here we go. We've tried it as 3 service counts. When we get to the third one, we're able to list secrets. So it's just kind of like showing the feature. So we're going to go now and set up and write out to a file kube control auth can I list as every service account. We'll just write it out to a file, and we'll exit Prioritization and look at that file. And I only have to look at the first one. Just I'll save you the effort of having to watch me more or less through the thing. And I find something really juicy. I find that this metal LB thing is allowed to create admission control webhooks. So it's allowed to delete them. So if there was one getting in my way, we could delete it. That'd be great. But also there isn't even one getting in my way in this compliant cluster. But because I can create webhooks, I can create a mutating one. And a mutating admission controller can change any resource, any pod that's being deployed to the cluster. It can change it on its way in. And so what we're going to do is we're going to go get the service count token for that metal LB one, and we're going to exit Prioritization just because Prioritization doesn't have the ability to do kube control, read this file yet. So I'm going to call Prioritization kube control. It's built from the same library, so it functions as a kube control. Our focus was like one static binary you can run even when you don't have a shell. And so I'll set up one of those aliases that uses the token. When I try to use it, I'm like, oh wait, I need the server. I'll go grab that server URL out of the kubelets config that's out in the file system. And once I do that, set up a new alias, I can find out I am metal LB controller. So I'm going to be able to create these mutating webhooks. And so I'm going to clear my screen, and I created this admission controller, short bit of Python. All you need is basically a web server that knows how to parse some JSON, change it, and kick it back out. So this one's going to say for anything that's in here that uses the internal registry, that it should take every single one of the pods from now on that's deployed to this cluster, and it should add a sidecar container, the same way Istio would. And our sidecar container generally goes unnoticed. Like somebody looking at this cluster on a dashboard is going to see the names of all the pods, but not the extra containers we've added. So we'll add this Istio, we'll add this sidecar. We're going to call it Istio, and then we'll activate our mutating admission controller and say whenever somebody creates or updates a pod, then it should go to that thing. So once I deploy that, and I have to do a little bit of work to upload it up from the system and so on. I guess a copy paste might have been a little faster, but I apply it, and now I can change every single pod. So what I want to do now is ask you, what do you think the actual criminals are doing? So I'm a pen tester. We just want shells. But what do you think the actual criminals are doing when they get to this situation, when they can go and put another program in every single pod in the cluster? Okay, show of hands. Who says data exfiltration? They're going to steal the data. Okay, good. Get all that PII. Who says ransomware? Cool, ransomware, that's a good source of money usually. Who says rocket like a pen tester, reverse shells? It's always more that way, yeah. Okay, well, you're all wrong. Turns out crypto mining is where it's at. So in the example where Tesla, very early in the Kubernetes journey, Tesla had an unauthenticated Kubernetes dashboard that had, I think, cluster admin. That's what happened. That's what got deployed. So, okay, I've got one more part to my demo, and that is I'm going to show you this tool KubeHound, and I'm going to do it for 2 minutes. So KubeHound, really cool tool. It takes a little bit of learning to learn their domain-specific language. However, you don't have to. I just took KubeHound, and this is our cluster, and I just said, let's run one of the sample queries. And let's see where we started from. We started from this pod called Holt, the Jupyter Holt pod, and I can follow this path. This is just like just like Bloodhound. So this path gets me to this identity. That identity was that Jupyter Hub default thing, and that'll get me to a permission set. I can read the permission set. Cool thing is I don't have to read the permission set to see that I can patch pods, because what this thing does is each one of the arrows represents basically an attack. So this says, hey, if you get to here, if you're in the Holt pod, go patch this other pod. Which pod should I patch? Okay, let's find out. Which pod should I patch? I should patch the one called Hub Grad Students. Oh, wasn't that the one we patched? And if I do that, I will end up in this container, which has the code server or not. Well, I will end up in this container. I got this identity, and that will give me these permissions, which are super dangerous because I can do all that. And if I trace through, I can find the entire attack path. So KubeHound, kind of cool, found our entire attack path. And that is the end of our demo. So what's my point? Well, what did we just do? Sorry. What did we just do? Apparently hop around with buttons. What did we just do? We just hacked a compliant CVE-free cluster. Got a perfect score, got a perfect no fails on the benchmark. So one of the big messages for us in this talk is to think about where you're prioritizing your time, your resources. So if you're early in your security journey, instead of going after perfect CVE management in your images, of fixing a whole bunch of things that weren't vulnerable, and perfect benchmark scores, or perfect hardening, perfect checklist scores, look at RBAC. Look at that authorization. Who's allowed to create pods? Who's allowed to read all the secrets? And look at admission control. Admission control would be how you actually stop me from launching privileged pods. What things are allowed to? Hopefully nobody. If you're allowed to create pods, don't let me create privileged pods with host PAD namespaces. There's a whole list of different configurations. We have a reference at the end that tells you different pod configurations that lead to breakouts. So, and then also I think prioritize just giving the team time to get familiar with Kubernetes. So cool. Final thoughts.
So you've seen a bunch of stuff. Let's put it all together into something, hopefully a coherent takeaway. We had this thesis in the beginning. And it's kind of like, hey, talking about all these attacks without talking about the risks leads to this misinterpretation of the threat models. And this is what we've seen when we compared notes between what Jay's seen in pen testing, what I've seen in my experience of we're not really defending from the right attack. So stuff we've seen in the real world and the stuff that we've talked about today, using a CNAP or like a runtime security tool to prevent some world-ending attacks of your RC environment, of your RC as a code environment, right? Building custom Seccomp profiles to mitigate threats that aren't necessarily likely to your organization. There's a lot of teams that are thinking through that. Spending too much time on CVEs and not enough time on the practical attacks. We've all seen this, not just even Kubernetes. Like we've all seen this kind of problem in our organizations. And one of the other big ones that we've talked to with the CIS benchmarks is this unilateral assertion of what the best practices are and what you should be doing in your clusters. And you must be CIS compliant, but without a practical roadmap to apply them to our own clusters and to understand the threats that we're mitigating. So you might take away that Kubernetes is always going to be complicated. It's always going to have this nuance that we have to be, it's going to be changing over time that we have to be kind of staying up to date with. There's not this silver bullet that I wish I could just go, hey, go to this website and like everything's going to get solved, or go buy this and everything's going to be solved. So it is what Jay's been saying about continuing education and practice and doing all the stuff that like nerds love to do, right? Just learning about the subject matter, and also risk prioritization of, hey, when people are talking about risk in different ways, we need to be talking about the right risks. Because you remember this slide, we talked about like humans are not really great at risk analysis. We kind of have this bias towards the scariest risks and the stuff that is kind of more interesting to talk about. And we have the same problem with Kubernetes. We're thinking about container breakouts. We're thinking about Linux kernel O days. We're thinking about those CVs that compliance is yelling at us about. But the stuff that Jay just went through in the demo is overprivileged RBAC and other types of misconfigurations that are much more likely that these are the things that we're exploiting all the time. Or like config maps used to store secrets, or the thing I just did yesterday, the kube delete the wrong cluster. How many people want to admit that they did that? Yeah, exactly. So like, whoops, what context am I in again? Yeah, so like these are the threats. We want to spend more time in the bottom right than the top left. And how do we actually do that? So our point here is to know your threats. We've seen all the talks at ShmooCon. Jay's presented, I've presented, we've read all the books, we've done all the training, we've done everything that maybe we know exactly everything that we need to know about Kubernetes, and we know all the fun attack paths and the cool scenarios and all the fun stuff, and we come away with like, here's the threats to your organization. Nation states and Russia and China is after us, and different malware actors like Team TNT are doing really interesting stuff, and script kiddies and malicious insiders. Like, these are the threats that we talk about a lot, but also there's other threats in your organization. If you remember like the different roles that teams have, your boss is a threat if you're not convincing your boss to invest in the right risk. Your boss has the job of just making sure the right resources get invested in the right areas, right? Though your boss is doing the right job, they're a manager, they're doing whatever, but it's your job to convince your boss that you should be investing in this risk, not this other risk over here. Compliance is doing their job saying like, hey, you said you're going to be CIS compliant, you should prove that. And you go, well, yeah, also we need to not just do that, and also these other risks need to be mitigated because we just compromised the cluster. We also need to talk about the board of directors that read some cool, article on an airplane, and they're all like really excited about this Kubernetes thing, and they're like, whoa, whoa, whoa. Here's the risk we should be concerned about, maybe not these ones. So it's our job to work with these people and not choose them as these are threats to your organizations or like they caused all these problems. It's like our job to convince them that we have to figure this out. And if you have to talk to the SEC, I think you're already fucked in the first place. So know your threats. You're the only one that can truly know the practical threats to your organization. And like that's your role in your team and your organization. And this is the last ShmooCon. So we can say, don't let people talking at podiums tell you how to secure your environments. Thank you very much. I'm Mark. This is Jay.
Mark won't say it because he's a little on the introvert side, but I will. Come talk to me. Come talk to me about Kubernetes. Come talk to me about neurodiversity if you want. Hell, if you're thinking about 3D printing, come talk to me about 3D printing. See what you can make out of plastic. Anyway, thank you.
One more comment. I just want to, this is the first talk for the kind of like the last day of ShmooCon. I just want to thank ShmooCon, and everybody else shares this perspective of like ShmooCon has given us a lot of our careers, a lot of our opportunities, a lot of our friends. So I'll never say it to Bruce, but like, yeah, let's appreciate ShmooCon. Bruce and Heidi, amazing.
Yeah.
We have 2 minutes for any questions or comments or shmooballs that want to be thrown at people's faces. Otherwise, you can see us after and buy us a drink. Thanks very much.
Cool.